welcome back to Manufacturing and Mobility Live. Thank you so much for all the questions you've been sending in so far. Just a reminder to put your name and where you're getting in touch from. Keep those questions short and sharp, and as ever, I get through as many as I can. Now, time for our next keynote with Rajesh Kumar, Chief Technological Scientist at Woxton University, and we are talking AI Research Centre, transforming the mobility industry with AI and IoT. Rajesh, how are you?
Yeah, I'm good. How are you?
Yeah, really good, thank you. Great to see you. The virtual floor is yours for your presentation, and I'll be back with some questions at the end.
Sure. Yes. So, good morning all. I'm Dr. Rajesh Kumar, KV. So, Chief Technological Scientist, AI Research Center, Woxton University, India. So, today my topic is about the transforming the mobility industry with AI and IoT. So AI and IoT is not a buzzwords. Nowadays, all the industries are transforming in that mobility and in mobility and transforming industry is also one of the part. So going forward, my presentation aligned with introduction to AI and IoT innovations in the mobility industry, tools for enhancing efficiency, safety and sustainability, a small discussions on AI applications in mobility, and also addressing the dilemmas and solutions in the context of new technologies for mobility. And also I'm showing the future directions in the transformation with the conclusion. All right. So everyone talking about the AI and then IoT innovations in all the sectors, not only the mobility industry. When you take about the healthcare industry, sports, or whatever the industry, now AI is rapidly evolving and then taking into the advancements in various sectors. So when it comes to the AI, artificial intelligence and IoT is reshaping the mobility industry. Safety and then convenience, how people and goods move. So these two are the main target in the mobility sector. When it comes to the AI and IoT together, will help to transform the real world applications and compared to the traditional transportation models. So especially focusing on the AI power. So AI powers many advancements in the mobility sector, enabling the vast amount of data to make the real-time decisions. For instance, if you take the machine learning algorithms, these are used to optimize routes, reduce congestions, and then traffic plan, improve traffic flow in the urban areas. And also in the autonomous systems, AI enables sensor data processing, object recognition, and then decision makings, and for making self-driving technology safer and more efficient. So if you see the technological advancements like starting optimizations and then traffic control, if you see the how smart the AI systems are recognizing the objects in the on the road, and then how the supply chain is moving, all these technologies you can track with the AI based algorithms. Not only that, AI supports the predictive maintenance, so which is nothing but the how the system is getting failure, and then how we can improve. All these things we can do with the predictive maintenance algorithms. Altogether, with the support of IoT devices, so this is the backbone for the AI algorithms, where data has been being generated from the IoT sensors and devices. IoT connects vehicles, infrastructures, and users, creating the vast network of devices that communicate and share information. So vehicle-to-vehicle communication, vehicle-to-infrastructure communication, these are the technologies where the backbone for the AI development. So IoT sensors in cars, buses, trucks continuously monitor parameters like speed, fuel consumption, engine health, all these parameters. These devices transmit real-time data to the central systems, which can be analyzed to the real-time insights to get from the real-time insights to the cloud computing or any other model. Moreover, IoT and edge dividers enables the vehicle to everything communication. Previously, it started like a vehicle to vehicle communication and then vehicle to infrastructure communication. Now vehicle to everything. So you can talk with every infrastructure. That is a smart traffic control systems or a smart mobility, you can see it. So by introducing these two words in the mobility and transformation, I'm going forward to the tools. So tools for enhancing efficiency, safety, and sustainability. So generally the traditional algorithms from the AI tools or frameworks. So these are the main important, starting from the AI-powered sensors. Comes to the AI-powered sensors, where the real-time data has been collected from the, and then if you identify the mobility patterns, and then you can automatically detect the traffic, so density of the traffic. So which will give you the much more impact on the real-time traffic condition. When it comes to the machine learning algorithms, it analyzes the historical data to predict traffic trends and then optimize transportation systems. This will give you the route optimization models as well. When it comes to the IoT platforms, integrating smart sensors to the vehicles or to infrastructure or vehicle-to-vehicle communication, IoT devices are the backbone for this. So starting from the sensor-based devices, which can be integrated to the vehicles. And then the most important thing is the geographic information system, GIS, mapping mobility hotspots and routes for efficient urban planning. So when it comes to the traditional AI methods, based on the sensors and then based on the algorithms, we can go for the predictive maintenance algorithms. So anticipating vehicle maintenance need to reduce downtime, which will improve the efficiency. So predictive maintenance is nothing but it automatically predicts the maintenance. So when it is the downtime, when it is the high time to change the any certain parts of the vehicle or any mobility or anything, if you want to plan, the predictive maintenance algorithms will automatically give you the notifications. When it comes to the anomaly detection algorithms, identifying abnormal driving patterns or mechanical issues in the vehicle, in the autonomous vehicles, it will algorithms will itself detect based on the historical data. And also the image recognition, detecting obstacles, road conditions, potholes in the real-time systems using the navigation model. And also optimizing algorithms, enhancing the route efficiency and reducing the fuel consumption through optimized driving patterns. So these are the traditional AI methods when it comes to the mobility and transformation. And also there is the generative AI based applications like a GANs and then AI driven renewable energy, AI powered simulations. So these kind of simulation models will help you to understand, suppose if in the base, if in the high scenario, simulating the potential traffic scenarios for the urban planning and safety testing. So if you come up with a simulation model in the urban area, then we can understand how to use the data driven models and then how to use the how to use the predictive models when it comes to the simulation data. We can't deploy the direct models onto the real world. So in the simulation environment itself, we can understand the scenarios. So these are the overview of the tools for enhancing efficiency, safety, and sustainability based on the AI and IoT integrated. Right. When discussions on AI applications in mobility, autonomous vehicles and driving assistance, predictive maintenance, smart traffic management and cognition control, enhanced public transportation systems, urban planning and infrastructure development. These 5 points I have going to be discussed. So these are the major problems and challenges during the transformation of the mobility systems. Right. So everyone knows about the autonomous vehicles. Already these are into the market and then on the roads also in the developed countries like US and China and UK as well. So Waymo, Baidu, and then Cruise from the US and China, they already developed and they deployed into the market and onto the roads. But what are the behind the technology? So there, since these all are into the product level and also in the real-time products, but still there is a chance to improve based on the algorithms properties. Like OpenCV and YOLO algorithms can be used for object detection, lane recognition, and obstacle avoidance in autonomous vehicles. And also when it comes to the sensors technology, LiDAR and radar sensors can be used to map obstacles detection in a different ways. When it comes to the processing support, NVIDIA Drive and Tesla FSD chips can be very helpful in optimizing the high-speed computations based on the AI algorithms and then in tracking in the real time. So these are the overview of the autonomous vehicles in the backbone. So when it comes to the development side, these will drive the autonomous systems in a different ways. So AI powered drive assistance systems like automatic braking and lane keeping assistance, and then further recognizing the safety and convenience. All these technologies, the backbone are these are the tools very helpful. So when it comes to the predictive maintenance, AI uses historical and real-time data to predict vehicle maintenance needs, reducing breakdowns and improving fleet efficiency. Predictive maintenance algorithms help identify wear and tear on vehicle components, when they will fail, when they will need repairs, and minimizing the downtime for the public transit and logistics fleet and private vehicles. So predictive maintenance is very important in the mobility sector. The tools like IoT sensors with the temperature and vibration sensors, these will be very helpful on getting the any information from the vehicles. And then machine learning algorithms, the frameworks like TensorFlow and Scikit-learn use it to analyze the sensor data and predict maintenance when it comes to the real-time data. And also, we require the IoT platform support and as well as the cloud integration like AWS or Azure or whatever the cloud. So which will enable the real-time analysis of the vehicle health for predictive maintenance. Already, these are the companies working on Uptake and others. So already they are into the market and they are on live. So we can take support as well as we can develop our customized models as well. So when it comes to the smart traffic management and cognition control, so AI algorithms optimize the traffic flow by analyzing the data from the cameras, sensors, and GPS devices across the city. If it is an urban city, so like I can say that from the Leeds city and as well as Kanpur city from the India, they have deployed the smart sensors across the city. From that, we can fetch the data and understand the real-time data analysis. So AI can adjust the traffic signals, suggest alternative routes, and reduce the congestion. This improves the travel times, decrease fuel consumption, also reduces emissions. When it comes to the tools, traffic monitoring cameras collect real-time data on traffic density, vehicle counts and flow patterns, detection, counter of the vehicles. All these things we can do with the AI algorithms. When it comes to the data analysis platforms, Power BI and Tableau will be useful for the visualizing the traffic patterns and understand the abnormalities during the data in the real time. And then machine learning models or the reinforcement learning models will optimize the traffic signal timings to reroute the traffic to reduce the congestion. Cisco, MioVision, and other traffic cam, all these companies are already into the market and they are offering the smart solutions. So when it comes to the enhanced public transportation systems, AI is enhancing public transportation by optimizing schedules, predicting passenger demand, and managing fleet maintenance. Machine learning models analyze the travel patterns to adapt services dynamically, ensuring that bus, trains, or whatever in the efficient manner to meet the public demand. AI also helps improve the passenger experience by providing real-time updates and tailored journey planning. So for these public transportation systems, GPS and IoT-based devices are very essential to keep the track of the location, status, and occupy for the public transport in the real time. And also PAS, passenger information systems, which can be integrated to the IoT devices. And also IBM Watson, Google Cloud-based AI platforms can be useful for analyzing the data. So already some countries like Israel and USA, they deployed into the market and public are already using these things. When it comes to the urban planning and infrastructure development, this is the major thing where we have to focus on the mobility and the transforming. AI assists urban planners in designing smart cities by analyzing the mobility data, identifying high traffic areas, planning for the future infrastructure needs. With AI, cities can plan more efficient layouts for roads, bikes lanes, and public transport routes. It also helps in creating sustainable solutions, such as integrating electric vehicles, charging stations, and also which will reduce the carbon footprint of transportation system. For planning of the urban model and infrastructure development, we need the GIS, like ArcGIS tools, and also AI-based models, which are from the deep learning and image analysis. And also simulation tools like AnyLogic can be helpful for developing the simulation urban traffic monitoring and also infrastructure management. And Siemens and Sidewalk Labs, and Sidewalk Labs, all these companies are already into the market, right? So those are the 5 major applications we can say for the mobility transformation. Now we are moving to the key dilemmas and solutions in the context of new technologies for mobility. Right. So I have taken the first dilemma, like a managing infrastructure adoption for new mobility technologies. So this is the statement 1. And then the challenge is, how can urban infrastructure can be adapted to accommodate autonomous vehicles and other mobility solutions? So this is the challenge 1. When this challenge can be implemented with the solution like implement smart infrastructure that can communicate with autonomous vehicles. This includes upgrading traffic signals, creating dedicated lines, and installing IoT-enabled sensors across urban environments. So practical example, a city in Kanpur and also Kanpur, India, and Leeds, UK, already they have used this kind of model to optimize the vehicle, to optimize the traffic, and then providing the smart solutions. Next, when it comes to the manufacturing sector, ensuring quality control with AI-based inspection systems in manufacturing. So this is the one statement. And what is the challenge? How can AI-based inspection systems can be integrated without compromising the accuracy and reliability of the quality control? For this, we need to use the machine learning algorithms with continuous updates based on the historical inspection of the data to improve accuracy and adaptability of the AI quality. So companies like Volkswagen, Ford, Siemens, etc., they are using the manufacturing models which employs the AI-powered vision systems. So vision-based inspections will be helpful to detect defect detection and continuously refines the model based on the new defect. So algorithm itself can be trained based on the historical data and provides the output based on the identifying the defects. So these 2 dilemmas, and then the key focus areas for the future directions in mobility transformation is nothing but these are the future directions. So when it comes to the autonomous delivery drones and robots, hyperloop and high-speed rail systems, battery swapping and ultra-fast EV charging systems, flying taxis and urban air mobility, quantum computing for traffic optimization, 5G-enabled vehicle communication, AI-powered predictive maintenance for fleet management, AR, augmented reality for navigation and driver assistance, blockchain for secure vehicle and data transition, and hydrogen fuel-based models. So these are the future directions where we can improve our current mobility systems, and then we can go forward with the high-level models. So when it comes to the conclusion, so these are the points. Advancements in mobility technology, like innovations like AI, IoT, autonomous systems, and sustainable energy are transforming transportation into a smarter and more efficient ecosystem. Enhanced safety and efficiency. Future mobility solutions promise reduced cognition, improved road safety, and more accessible transportation options. Sustainable and eco-friendly solutions are like technologies such as electric vehicles, green energy integration, and urban air mobility contribute to reducing emissions and also environmental impact. So when it comes to the challenges to address, key obstacles are like cybersecurity, data privacy, infrastructure adoption must be overcome to fully realize the potential of new mobility solution. A vision for connected future is nothing but the connected of technologies, nothing but the infusion or interdisciplinary research should come up with the technologies fusion, like AI, IoT, AR, VR, or any other technologies we can come up, and then we can provide a sustainable solutions as well. Watson University is active. Yeah.
Okay, Rajesh, thank you very much indeed. Absolutely fascinating presentation. A couple of questions for me to start with. You were going into some of those fantastic examples about how different technologies are being used in different areas around the world. Do you see there a time where a lot of this will become standardized? A lot of it at the moment is slightly experimental or testing or breaking new ground. Do you see standardization coming?
Yes. So already many products are into the market, like Google and then Waymo Baidu, many companies are already launched their products as a real-time into the market and also onto the roads. But at the back end, there is a research is also going on. Especially from my lab, we are developing some algorithms to optimize the models in a simulation environment. So these kind of research based on the AI, deep learning, and reinforcement learning algorithms will help to come up with a smart traffic control systems or smart traffic cognition systems to avoid the flow. And then also we can also these algorithms can help you to come up with a good predictive maintenance systems.
Let's quickly go to some questions we've had in from the audience. First one from Elizabeth. Thank you for your question. So Rajesh, where do you see the biggest need for mobility solutions or AI in the next 5 years that most people maybe wouldn't expect?
So when it comes to the mobility systems, we need the future directions with the 5G communications, like we need the high-speed internet, and then we need some smart computing systems with the high power, like NVIDIA or maybe with the other companies can come up with a high-speed computing capabilities. So these will help you to come up with a real-time and accurate models.
And a final question from Jawad Ahmed Manki. Thank you very much indeed. My question is, if we introduce remotely operated or controlled small driverless logistics vehicles for distribution, what do you see as the technological challenges there?
So technological challenges is like data privacy, the first one, and then cybersecurity, infrastructure management, as we need to focus on.
Okay, challenges to overcome. Rajesh Kumar, thank you so much. Lovely response from the audience as well, thanking you for your presentation. So thank you so much for joining us here at Manufacturing and Mobility Live.
For the opportunity.
Thank you so much. Okay, let's move on. Time for a very quick break and we'll be back.